Good day, everyone. So, today we are going into questions and answers on radioactivity. Yes, calculation questions. Let's dive into this. All right, example one says in 24 days, a radioactive isotope decreased in mass from 64 grams to 2 grams. What is the half-life of the radioactive material? Okay, as our usual practice, let's write our parameters out. In 24 days, that is the time for the radioactive isotope to decay. 24 days, that's the T. And then, before the radioactive isotope decay, the initial mass is N0, so N0 is 64 grams. Now, after 24 days, the remaining mass is N, which is 2 grams. Okay, now we have to find the half-life, that's the capital T. So by formula, the half-life will be 0.693 T, small letter T over natural log of the ratio of N naught over N, where the N naught is the mass of the isotope before decay occur, before disintegration occur or decay occur, and then the N is the remaining mass after decay. So we have all the parameters available in the question. So substituting the value, our T, our small t is 24. So we have 0.693 times 24 log, natural log of N naught, which is 64 over N, which is 2. So in our calculator, we have natural log with it. Sometimes we call it a lane. So if you punch calculator with these values, we have our half-life, capital T, to be 4.8 days. So it will take 4.8 days for half of this isotope to decay. Alright, let's take another example. You say the half-life of a radioactive material is 6 hours. What that means is that after 6 hours, half of this material will decay off or will disintegrate. So now the question is, what quantity of 1 kilogram of the material will decay in 24 hours? So we have to find the amount of quantity that will decay this time around and not the remaining material. So let's write our parameters out. The half-life of the material is given to be 6 hours. So half-life is capital T. So capital T is 6 hours. So what quantity of 1 kilogram? That means before the material decay, the N naught is 1 kilogram. That N naught means as 0 time when decaying has not occurred, the mass is 1 kilogram. Now we are now told to find the amount that decay after 24 hours. That is our small t. So quantity decay by formula is N naught open bracket 1 minus 1 over Euler constant. The Euler constant is small letter e raised to power 0.693 t over capital T. Right? Now our N naught is 1, so we have 1. Okay. Substituting our value now, 1 minus 1 all over 0.693 times our small letter t is 24, 2 times 24 over this small letter e is known as Euler's constant. It's a constant, and the value of the constant is 2.71828. Then our capital T, which is 6, is this here. So when you simplify all of this carefully with the calculator, the quantity that decay is 15 over 16 kilogram. All right. So moving on, another example. It says a radioactive sample initially contains N atoms. After 3 half-lives, the number of atoms that have disintegrated is what? Okay. Very simple too. Let's write our parameters out. A radioactive sample has this atom that is at n naught when there is no disintegration. So our n naught is n. When at time 0, the mass is n in this question, according to this question. Now we have to now find the number of atoms that decay after 3 half-life. 3 half-life now is number of half-life n is equal to 3. Now by formula, to get number of atoms that decay will be equal to n naught open bracket 1 minus 1 over Euler's constant to the power 0.693 n. Of course, our n naught is given to be n. In this question, it's not a number this time around. The initial mass before decay occur. So that means n naught is n now. Open bracket 1 minus 1 over. Our Euler constant is 2.71828. Then raised to the power 0.693 times our n, number of half-life, that's 3 times 3. So when you simplify all of these, we have this to be approximately 7n over 8. So this is the amount that decay after 3 half-lives. Yeah, let's take another example. Here it says the half-life of a radioactive element is 24 hours. Calculate the fraction of the original element that disintegrated in 96 hours. Okay, now the half-life capital T is 24 hours as given in the question. We are meant to calculate the quantity that decay or the fraction that decay. So that's our unknown here. And we are told that the time for it to decay is 96 hours. So that's our small t. So the quantity decay by formula is n naught open bracket 1 minus 1 over Euler constant raised to power 0.693 t all over capital T. Alright? So in this case, we are not giving our n naught in the questions, but we can use it. You can still use it in the formula. So n naught open bracket 1 minus 1 all over Euler constant, which that's E. That E is 2.71828, and then 0.693 is there, times our small t is 96 times 96 all over 24. That's our capital T applied. So when you simplify all of this, you have a value to be 15 over 16 n naught. Since n naught is not given in the question, that's the original mass before decay occur. So that is the amount of substance that decay after 96 hours. Alright, so let's take the last question for today. Here it says a radioactive isotope has a half-life of 8 days. What fraction of the atoms will remain after 72 days? Okay, so the half-life is given to be 8 days. That's our capital T. Okay, we have to find the fraction that remain now. That's our n. N represents the remaining substance after decay. Then we are given the time for decay to occur 72 days. That's our small t now. So by formula, amount that remain is equal to the original amount all over Euler constant raised to power 0.693 small t over capital T. Alright, now substituting the value, we have n naught all over Euler's constant is 2.71828, then raised to power 0.693 times our t is 72, then over capital T, which is 8. When you simplify all of these, we have this to be 1 over 511 n naught. Alright, so this is where we shall be drawing the curtain today. Thank you for listening. Bye for now.